All right, so can everyone see my screen up there? The GitHub. All right, cool. So we'll go through the usual process here. I'm gonna fork it. So here's the challenge: November Platoon School Interface 2. So I fork it. And so now it's mine. It's in my repo. I'll clone my version. All right, so now I've got it here. And is this, let's see. Is this big enough for everyone? Yes, and let's take a look at the readme. So we started this yesterday. We've got our school interface. We have a few classes here. We have person, which is a super class, and we have staff and student, which are subclasses, and also school. So we've got a few classes. We need to figure out how to get them to interact. So we'll be adding, this time is a menu, an interactive menu. So we can go ahead and actually paste that in a runner. So we'll find the runner, and we can get rid of these lines, paste in the runner, and if we run it, okay, we get this menu printed out. We don't really do anything right now, but this gives us a general overview of what we're going to do. So list all students. We can see that we have some of this functionality already built. So we go to student, we see we're getting all of our students. If we go to school, person, student. So some of this stuff is built in, or at least we have the basic information that we need to start doing this stuff. So when we talk about the formatting, so you can always add new line to use an escape character, the backslash with n, that'll print the new line. So we're gonna do the same thing here. We'll just copy this. So instead of just printing it out, we'll be able to get input from the user. We've seen this before, so I don't want to spend too much time there. Shouldn't be anything terribly new. So I can press 1. It's not gonna do anything now, but I can give input and then grab that and save that input to a variable and then use that later on in the application. Okay, so we're gonna, copy and paste this in. It's gonna look a lot like what we have before. So we're still creating an instance of our school, passing in Ridgemont High. We now have our menu here, and this not so good to look at here, but formatted well on the terminal. And then we can actually choose a mode. So mode will be the value that we grab from the user. Then we're going to call, if they choose 1, that means they want to list all students. So we'll call school.listStudents. If we go to school, you can see that we have nothing called list students. So if we try to run this, call 1, we'll get an attribute error. So school object has no attribute list students. So we can go ahead and fix that immediately. We'll do, what is it called? List. And this isn't going to do anything, of course, but we'll go here, press 1, and nothing happens, but we don't get an error. So now we have the method. This method is able to be called from the runner. So we have an instance of school. We're calling the list students method, and nothing has happened. At least we're not getting an error. Okay, so let's see. So we have to run the runner, enter 1, we get the error. So we want to print out a numbered list of student names followed by their school IDs. Okay, so it looks like we're gonna be taking all of our students and then basically printing out a formatted output. So let's look at our school. So list students. It looks like we have access to all the students here from the previous day's challenge. And these are, and this was maybe confusing for a lot of people. So this is a list of student instances. So this may seem counterintuitive. Typically we think of, okay, we have an array, we want to have, like values, we're going to have strings and numbers and things like that, but you can have anything in an array. You can have functions, you can have an array full of functions, you can have an array full of classes, you can have an array full of class instances, anything, because everything is basically an object, it can be treated like an object, you can do that. All right, so we have access to all the basic information that we need. So let's just go ahead and print that out and see what we have. So if we want to access every single element in an array, and we know that this is returning an array because we can go to student. So we're importing student from classes.student. You see the file right here, student, and then objects method. We can see that what it returns. It's returning an array. So we know that self.students is going to be an array. So for student in students, so let's just try doing that. We'll run this again, press 1, and we're printing out all of our student objects. Of course, this is not very useful. We want this very nicely formatted string with name and ID and so on. So let's go ahead and print out the name. So because a student instance, it's an instance, you can treat it like an object, you can access its properties. So we'll access the name property. Okay, so now we're printing out all of the student instances names. So we're not gonna have to do a whole lot more than this. So we'll take all of the student objects and we'll format them accordingly. So instead of printing just the name, I'll create a nice format string. And notice here that we need a number. So 1, 2, 3, 4, 5, 6. So how are we going to get that? There's more than one way to do this, but we can, instead of just iterating over the array, we can use Enumerate, which is going to create a tuple for us that we can, it's going to have the index. So enumerate, and we need to get the second term here. So I student, and we'll do, since the index is going to start at 0, we need to start at 1. So we'll do I plus 1, and then dot space, and it looks like we need name and then ID. So student dot name and then space and student dot I think it's school ID. We'll see if that's right. So 1, and it looks like my output is correct. So 1, Lisa, and so on, right? So that looks the same. Okay, so looks like that works. So that's release 0. I can now call that method, I can access it and print out the result. Okay, so we're gonna build this up a little bit. Right now we can only choose one option. If we look at our runner, we only get to choose one option. So we're gonna paste this in, and this is gonna set up things for us to be able to add a second option. So this should still work. Let's just double check that and make sure it still works. So 1, okay, so 1 still works. I can still access all of my students. Mode, mode number 2 will be view individual student. So we have a student ID, so you're gonna have to get some input from the user. And then we'll do find student by ID. So let's take a look at where that is. So this is school. So I have this here, an instance of school, which is being imported. So this is the class imported from classes.school. So if we trace this back, we go to school, and we have a, looks like find students by, find student by ID method, which appears to not exist right now. So it looks like we'll have to write that. Let's just go ahead and run this and make sure, see if we missed anything. Press number 2, enter student ID. And we get the same error that we had with number 1. So we have an attribute error, school object has no attribute, find student by ID. Okay, so what I'm gonna do is, just for the sake of my own sanity, I'm gonna go ahead and add a student with a very simple ID, so I don't have to keep typing in a long one. So his ID is gonna be 123. So we look back at the README, it looks like we're gonna have to build this out as we just saw. So in school.py, define a method, find student by ID, which is right here, that takes in an ID and returns the student with the matching ID. Okay, so that shouldn't be a whole lot more different than what we're doing. So we have a list of all the students and we can print them all out. So it looks like what we need to do is basically iterate over everything and search. So probably linear search for this particular data set will be really the only possibility, just at least the most sensible for now, because our data isn't sorted or anything like that. So def, so the method is going to be called find student by ID. It's going to take a student ID as a parameter. All right, so how should we do this? So we need to iterate over every single student object in our students array, and we need to check if the student object's ID matches the ID that we put in. It doesn't really tell us what we should output. I don't think that it does. So for now, we'll just go with, true if there's a hit and false if there isn't. We might come back and modify that later. So we're going to iterate, same thing. So for student in self.student, and here we're going to do a check. So if student dot school ID equals the student ID that we're passing in, and we'll return true. And if we go through everything and we don't get a hit, then we'll return false. So that should work. Let's give it a try. We'll run our runner again. We'll try number 2. Okay, we don't get an error. That means that the method exists. We'll try adding our 123 ID, and we get true. We can try running that again with a false 1, 2, 3, 4. We don't have anyone 1, 2, 3, 4, and it returns false. So it looks like that basically works right now. Are there any questions so far? Okay, so we'll move on to release 2. And what we're going to do here is overwrite the Thunder string method. So let's do that. So our student class. So we're going to have to do this in the student class. And we'll check that out. So we'll go to the student class. Here we have, so we've you know, overridden the init. Let's also override the string, the dunder string. So the overriding the dunder string, there are two very similar methods like this. One is called repr. So the other one is string, and oftentimes they have the same output, but repr, I believe, is mostly used for displaying almost like a callable version of what you're doing. So if you have a class, then you would display like class name parentheses and then whatever parameters go in there. Whereas string is a little bit looser. It's not necessarily supposed to be invoked or used. But I think this example is a little bit, it's kind of pushing it, to be honest. This is a little bit more elaborate than you probably typically want to do for overriding the string method, but it's fine. So you can do whatever you want. So let's go ahead and try to override this. So if we override the string, so we can look up the string method, how it works, but it's just going to return a string. So you have to return a string. That's the only real rule here. So we're going to return something, and that something is going to be a string, and this is what we want to see whenever we just print the object. So if this is still up there, so up here, by default, when we just print an instance of a class, Python does this for us, and we're just going to override that and give ourselves something a little bit more useful, to a human. Okay, so we can also do a formatted string. So it looks like it's going to be something like the capitalized name. So we can start with that. So we'll do self.name upper. So we'll capitalize the name. And then we've got a new line, and then we've got some dashes. So we'll add the new line here, and then we can add some dashes. So we can use the multiply operator in Python, like that. So we'll have 20 dashes, and then a new line, and then age. So new line, and then we'll do self.age, and then another new line, and it looks like what is it? ID. We can try doing that. Let's see. Where are we printing out a print? Okay, so we'll print a student here if we choose to. So we'll run this again. Oh, I got an issue with my string. So f string, that's closing brackets. Oh, I think using double quotes inside of double quotes, which it doesn't like. Okay, so we run this, and we'll try. Where's this? So we'll try 2. We'll enter a student ID, and true. Print string.student. Don't think that actually printed anything.
I think it's in your school class, right? Return true.
For the runner, so school that finds student by ID.
In school, you're returning an instant. You're returning a Boolean instead of the instance of student that you found.
Oh, okay. Thank you very much. So it looks like the return value does matter. Thank you. So I'll return the student. Let's try 2 again. Do 3. Student object has no attribute ID. So we'll go back here. It's not self.id, it's self.school ID. Okay, so it looks like that eventually worked. So we enter the student ID. Wow, it's pretty cool. I don't know how I'm doing that. And then, yeah, so we got Bob. So this is the representation that we're telling. So when we just print the, the class itself, we're gonna, Python is gonna call the lender string method. And since we've overridden it, it will do whatever we told it to do, which in this case was output it like this. All right, so the third release is quit. So it looks like we need to add code to runner.py so that after showing the list of students, the menu displays again. The user can input another selection. So we need quit, and then we need to be able to keep going. So as it is right now, we run it, we choose one thing, it does whatever we tell it to, and then it stops running. So we're gonna have to make this keep running. So the way you basically do that is a while loop. So while true. We'll just wrap all of this in a while loop. And then, so this should run. We'll go ahead and see if this works. So this is an infinite loop, right? So on the one hand, maybe this is a bad idea, but this is just how these things work. So it is going to stop and pause. So it's not going to keep just printing stuff out over and over again, but we are stuck in an infinite loop right now. So if I do 1, it's going to print everything out and then immediately go back and start doing everything again. 2. Computer is very slow for some reason. Okay, so we'll do Control C and get out of that. But so now we have a loop, so we can keep entering new options over and over again, but we also need to be able to get out of the loop or quit. So we'll add something here. Looks like it's got to be 5. Then we will do, we could do, I mean, there's a few different things. So just that exit, we'll import. These are some, this is a, again, built-in Python from the standard library.
Is there a reason you use that over just the quit?
Not really. I would guess that quit probably is just an alias for sys.exit anyway. I'm not sure about that. But. So you can quit with an error. So this is like a normal quit. This should be normal quit. If you do quit 1, it'll show an error. So let me just try quitting here. Okay, so that was a normal quit. If I make this a 1, then that's basically saying there is an error and quit. So you can't really see a difference, but the way my bash profile is set up, if there's an error, if the last command ended with an error, it'll be red X. So this is normal exit. This is expected behavior. So we'll make this a 0. And if we do 1, okay. I can also add, because as soon as I print out stuff, it prints out everything else. So I can just add, if I can make this slow down, I can just add kind of a dummy input statement here. If I run this, I can list the students, then it'll hang there until I press enter again. Then I can move on to the next thing, do 2. and it just kind of hangs there until I press enter. So it's a little easier to read. And I'll quit now.
Hey, Chad, what's the difference between sys.exit and just using break?
So in effect, I don't know that there would be much of a difference. So it would just complete the execution of our program. So it would break out of the while loop, and then since there's nothing else, it would go. I realized, sorry, I'm sure the keyboard strokes are especially loud. Okay. Can you guys hear me? Okay. Yeah, so yeah, there's more than one way to do this. I'm not sure what necessarily what the best one is. I don't know. Does anyone have any thoughts on the use?
It just really depends. If you have cleanup code that you need to do, then the break would be better, because then you would be able to just fall into whatever you needed to clean up. So you have a file open that you need to close, that would give you the place to handle that.
Yeah, so that's a good point. Thinking about cleanup, it's important. So for this particular case, I don't know. I don't know that I would be able to make a strong case either way, but there are definitely situations where you might prefer one or the other. Okay, so it looks like we've got all the basics figured out, except that we have no tests, which is, not the end of the world. We obviously can make do without tests. Who needs tests? But we'll write some tests anyway, because that's what we're supposed to do. And we're good people, so we'll write tests. And I'm just going to focus on, we'll test the school, just for the sake of simplicity, since I don't want to spend the next 2 hours doing this. So all right, school test.py. So we'll use unit test for this. Not a big surprise there. So in order to do that, we'll import unit test from Python standard library, and then we'll have to subclass. So we're going to inherit from unit test.test case, and we'll make our own class. Class school test, and we'll do unit test.test case. And I'm going to skip the doc strings and stuff, but you should be writing doc strings. And then we'll do pass for now. And then we're also going to need to call unit test.main. So unit test.main. You could also do the if name equals main thing, but here doesn't really make much difference. So we'll just call unit test.main at the bottom. And now we've got our school tests set up. So we're going to have to write some tests. We're going to test the school class. So if all of our tests are going to be on the school class, we might as well save ourselves some work. We're talking about tearing stuff down in a second ago, but we can also build stuff up. So we could every time we run a test, create a new instance of the class and so on. But we can also unit test as a way of allowing this to set stuff up. So we'll do something called, there's a built-in method called setup class. So def setup class. And this is actually going to be a class method. We'll have to add the decorator here. All right, and then we're just going to tell it what to do. And what we want to do is create an instance of school that all the tests can share. So we're going to have to import school. And so notice where we are in the directory structure. So we have our tests here, and it's parallel to the classes, where all of our classes are. So what happens when we go to import? So from classes dot school import school, and we'll do something like equals so if we try to run this, let's go to CD tests. And you get a module error. So this is a kind of a pain, you know, dealing with imports is a pain for sure. There's a couple things we could do. I think the easiest one is to, again, import sys, so Python's standard part of Python standard library that allows you to do things with the file system, especially so there's, you know, there's OS, there's sys, so a lot of like very kind of lower level ways to interact with your computer. So sys, so we'll import sys, and then we'll do sys.path append, and we'll do // So let's try running that again, and this time it works. So we're basically saying, hey, when you look, you know, the default path that you use, just start from one directory above the current directory. Okay, so we're able to access our class now. We have our setup going. Let me do this. Shared. Okay. And all right, so that should be good. So now I've got this class method, which I'm using to set up all the tests that are going to run here. And I'm just creating something that basically any test that I run in the instance will be able to access this. So I just have to create it once, and then I can use it anywhere. All right, so let's go to our school file real quick so we can see that school there's not a whole lot going on here. So we have one function that's just printing, another function that's returning a student object. This is going to be kind of hard to test, right? So we just have one function that actually returns something. We can start there. Let's start with find student by ID. So test find student by ID, and so we'll test a missing student, and we'll do an assert equal. I gotta use def. So self.assert equal. So what I want to test here is I basically want to give it an ID that doesn't exist and see if it returns false. So I'll just write that out first. So we'll call the shared instance. So self.shared instance. This is going to be our school instance. And we'll call the, what is it? Get students. Find student by ID. I'm also going to import that here. School import school. So we're going to find students by ID, and we're going to pass it something that doesn't exist, 1, 2, 3, 4. And we're going to want to assert that this is false. So self.assert equal. assert that this is false. Let's try running that. And it looks like it passed. Okay, so this is returning false if I give it a dummy value. Let's do something similar. So you can try testing this again. This time, if something is found. One, two, three, four. And so assert equal may not be exactly what we're looking for. So we're going to get a student object here. So we could do something like dot name. So we can check the type. So assert is this is a little wonky maybe, but
I usually use assert true, but I mean that probably does the same thing.
yeah, there's a bunch of these assert statements, and a lot of them kind of do the same thing. Or you can like, I mean, you could make assert equal kind of do everything that you want it to do. So, but yeah. So here we're just checking the type. So we call this student, it's there, it should return a student object, which should have a name property. So this is not the most direct way of testing this, but I think it'll work for now. Okay. So we have one function tested, which is good. What about, how do we test list students?
We should know how many students there are, and you could test to see if the print, whatever's printed, is a certain number of lines long.
Okay, so how do you test if something is, so what is, I guess, you know, we talked about functional programming a little bit. So this is an example of what kind, is this a pure function or an impure function?
The test that we would be writing, or the list students?
The list students.
The list students
It should be pure.
doesn't change anything, so it should be pure.
But it does change something.
What does it change?
Changes standard output. So it has
Oh, wow. Okay.
it has a side effect. So yes, it returns none, so it will return the same thing every time, but it has a side effect, which is printing to the console. So that
Is the test to check if something gets printed to the console?
so we will end up doing that, but I just want to point out that this is an example of an impure function, and testing print statements is difficult to do and kind of indirect. So if you want to make things easy to test, it's best to maximize the number of pure functions that you have. So what we'll do here is, in order to kind of increase the testing surface of this very sparse class, is we'll add another method that will actually return all of the students, and we will be able to test that. And then we'll just use this purely for printing. So this is, you know, again, if we think about breaking up our functionality into smaller units, this is kind of doing two things, right? This is getting all of the students and then printing them out. We can.
So you would make a function called like get list of students that returns a
Sounds good
list,
to me.
and another one that says print list of students.
Yeah. So this is not, you know, it's not strictly necessary. This is just a design decision. But if we want to increase the testing surface of our application, then again, you want to maximize pure functions. So you want functions that I can give them a parameter, or in this case, we're not really giving it a parameter, but it's an instance attribute, and it will return something. So it's not just doing a side effect, it's not printing the standard output or anything like that. It's returning a value that we can examine easily with our unit tests. All right, so we'll basically do the same thing here. So we're just gonna need to list over everything, but we're gonna store kind of an abstract representation of a student, just grabbing the three properties that we need, which is the number, the name, and the ID. So, whoops. Student stuff, terrible name, is this. And then what we'll do is we will loop over it. And then we'll append. And we'll append a tuple, just again, just like to remind everyone that these exist. So we'll do I plus 1 student dot name and student dot school ID, and we will return student stuff. Okay. So now we have another function, and we can actually test this. So before, it's difficult to test this. We will kind of be able to test printing output, but it's not quite as robust. Here we pulled out some of the functionality, so now we can test directly. You can add unit tests, and we'll just use list students to print. So what we'll do is for student student representation, whatever, in self that, and we'll call the function here, get list of students. What we can do is we'll do a print statement. But we're not going to have this, so we'll do student representation, the 0th, the 1st, and the 2nd. So let's go ahead and just try running our application to make sure we didn't break anything while we were messing around with that. Okay, Python. Okay, cool. And we'll try listing all students. Looks like that works. So it looks the same to me. I'll assume that it actually is the same. But so we've kind of like, on the one hand, we've added maybe some complexity and maybe some redundancy, but we've also made it easier to test. So let's write a test for get list of students right here. Get lists of students. So let's do returns. So again, we could write some more robust. This will be kind of notional. You could write 2 or 3 tests to test different aspects of this, but so we want to call self dot get list of students, and we want that to return an array. So we could do, or a list, we'll do self dot assert. Whoops, assert is, and we'll check the that should list, and we'll do By the way, I think checking type is not very Pythonic, so I apologize to purists out there, but let's see, school tests. We'll get list of students.
You just need shared
chat.
instance.
Yeah,
I just wanted to add that there is a self dot is instance instead of needing to use self dot assert is type.
okay. Let's try that, assert is instance. Thank you very much, cool, we'll try that one out. Let's see, I'm getting an error here. Instance has no get list of students member.
You just need dot shared instance before it. After self.
Oh, thank you. Yeah, thank you.
Also, you don't need to call type within assert is instance.
Thank you very much. Okay. So I think that should be, let's see, should be cleared up now. All right, let's try running the test. My computer's lagging today. Okay, so that passed. So that's good. We'll just, we could investigate that more to make sure. Ideally, you want to fail the test first before you write it, just to make sure, it's actually doing what you think it does. Okay, so now we can, so we've just added some, testable service area to our code. What about this thing? We're still printing something. So you can actually test print statements or, standard output, but it's a bit, it's a little convoluted. But I'll just show you something you can do. So Python has a built-in mock. So there's a mock object that you can invoke, and there's something called patch. So patch is a function you can use as a decorator on your functions. You basically fake certain things, so we'll basically be capturing student out. We'll be capturing the standard output, and then we can check it. So this will be a bit weird. We'll use a decorator patch, and we're gonna want to basically mock. So we're gonna want to hijack standard out sys.std out. So this is where your print statements go, and we have imported sys already. So we're gonna import that and new callable. This is just something you have to pass in. Oh. And this will be io.string io. This is something built in to the Python standard library. We'll have to import it. IO is input output, so input output operations like printing. Okay, so we have a decorator. So this is gonna basically modify. So we'll write a normal test case, but this patch decorator is gonna modify what we're doing. It's gonna hijack our normal print statement. So def test, and we will test. What is this one called? List students. And here we're gonna have to pass in another parameter because this decorator. So decorator is a function that you give so it's a higher order function. Takes in a function, then it will modify the parameters. In this case, doesn't always have to modify the parameters, but often that's why you use decorators. So we'll do. So it's going to pass in, it's going to add another parameter to the function that we have, and it's going to pass in this mock standard out object. And so now we're going to call the function that we want. So we'll do self.shared resource or shared instance. what is this called? Shared instance. Self.shared instance dot, and then the function is list students. That is what it's called, right? Double check. But yeah, list students. And so it's going to call that, and then when it prints, so the output, there's a side effect. The function is going to print to standard output, and we'll capture that, and then we can check it. So we'll do mock. This is a bit weird, so again, don't worry if you don't understand it. It took me a while to figure this out last night. So dot split. So it will actually give you, if you do the get value, so this mock object is going to capture the output from the print statement. And we could actually check the whole thing if we wanted to format like the whole string, but I just don't want to type that much. So I'm just going to split it on a new line and just look at the first example. So split it on the new line and 0. And that one should equal the first person in our students file. So it should look like this, basically, whatever we're printing to standard out. So let's go back to the test. And we're going to call assert equal. So self.assert equal. And we're going to test that the output is Lisa and space something else. One, 2, 3, 4, 5. All right, so let's go ahead and we'll try running that. Patch is not defined, so I'm going to have to import it. So we're going to import unit test, and from unit test dot mock import patch. So here we're importing unit test, which is just kind of makes the whole thing available. We could also just call this, instead of patch, we could call it unit test dot mock dot patch, and that would be fine as well. But you can also import it like this, and then you can use patch directly without qualifying it. Okay, this computer's being very slow. Okay, so that test ran, and what if I change this? It will fail, and it's telling me that it expects this with a 5, and it actually got this. So if we wanted to see everything that was available in the print statement, we could also just do this. So it's an abbreviated summary just displayed here, but this will be an array of everything that's printed. But that should get that's the general idea. So as far as testing goes, testing pure functions is much, much easier. So the more pure functions that you have, the easier it is to test your code. But that's not, 100% pure is not really feasible, especially with web development, because you're constantly making API calls or getting user input and all that stuff. So all that's impure. But what you can do is try to isolate the impurity. So that's basically that. Are there questions?
So basically, when you're isolating, you're just getting to the point to where you would basically do everything up to making the call, and then have the call be a separate function, so it wouldn't be mixing the two together, and you can test that the call is correct. So like it should be hitting API endpoint blah blah blah, and it's passing this query string, and that would be how you'd run your test.
Yeah, so there are a few different ways to deal with it. So even an API call is an impure function, and if you're doing unit tests, you're probably going to want to mock the API call, because you know you don't necessarily want to, you don't want your unit test to be dependent on having a good internet connection, or the API being up, or maybe there's unique credentials. So there's all kinds of issues with testing impure functions, which is why mocking exists. So that's why there's a mock object. And if all functions were pure, you wouldn't need a mock object.
So what I was getting is I guess you were saying that, yes, you would need to test that build of what the API call would be, and then make the mock object to test the API call portion itself.
Yeah, so you can make a mock object, you can mock a return value. So you do something like that.
Cool.
It can get fairly complicated, and there are different, this is just, this is the built-in Python unit test. In JavaScript, there's a lot of libraries that do that. So we've looked at Jest a little bit too. So there's definitely a lot of complex things you can do. All right, I will stop sharing.